Hey everybody, it's Mr. P again, coming to you with your ICP learning lesson for Tuesday, May 5th. Okay, and we're continuing in our electricity unit. So far, to recap what we did last time, we established what voltage, resistance, and current are. Okay, so remember, current is the amount of charge flowing through the system, the rate at which it's flowing. Voltage. Okay, that's the potential difference. So remember, we said the more voltage there is, the more current that's flowing through the system. Resistance is what inhibits or slows down the current and restricts the amount of charge. And we're going to see how voltage, current, and resistance are related to each other. Okay, and this is going to be through something we call Ohm's law. All right, so according to Ohm's law, the voltage in a circuit is equal to the product of the current and the resistance. What does product mean? What do we do with the numbers? Okay, we're multiplying. So this is saying the voltage equals the current, which we represent with the letter I, don't ask me why, times the resistance, which we represent with the letter R. Okay, so voltage equals current times resistance. Okay, and recall that we established units before. Voltage, remember that's in volts, or we just represent that with V. Current, remember that's in amps or A. And resistance, okay, resistance is in ohms and represented with the Greek letter omega. Okay, so increasing the voltage, which we kind of already talked about in the system, increases the current. Okay, so the amount of charge flowing through the system. If we keep the same voltage, however, and let's say we increase the resistance, remember we talked about this. If we increase the resistance, we restrict the flow of charge, so this would decrease the amount of current. This would decrease the amount of current that flows through the system. All right, so, if we look here, little symbols I have here. So as voltage goes up, current goes up. As voltage goes down, current's going to go down. And here, again, just like we stated up here, voltage is constant, V is constant. Then as we increase the resistance, the current goes down. Or if we decrease the resistance, the current's going to go up. More charge will flow, the less resistance we have. We talked about, different amounts of resistance depending on the thickness or the length of a wire, right? We said like a thicker wire has less resistance, more places for the charge to flow. And, a shorter wire would have more resistance because there's less distance for it to flow, and vice versa. So let me just show you a little graphic here on Ohm's law and the relationship between voltage, resistance, and current. So we can see if we alter the voltage. So if I increase my voltage, notice what's happening to the current. The current is also increasing. If I decrease the voltage, my current also increases. Remember, V represents voltage, I represents current. If I keep the voltage the same, and let's say I increase the resistance. So it says the resistance gets larger, the current, what's happening to it? It's getting smaller, right? Because if we increase the resistance, we're increasing the restriction on the flow of charge, and we're decreasing the current. Okay, if I decrease the resistance, we see the current gets larger, right? Less resistance, more current can flow. Okay, so let's go back. So again, voltage equals current times resistance. As we increase the voltage, the current increases. Resistance and current are inversely related. Okay, as one is increased, the other decreases. Let's look at a few calculations. Okay, so your practice on this section here will consist of problems It's very similar to what we're going to practice right now with our examples, where we're calculating your voltage, resistance, for current. So we always want to start with Ohm's law, V equals IR. Voltage equals current times resistance. Okay, it says calculate the voltage of a battery. So what are we trying to find? The voltage. Where the resistance is 2 ohms, so label that R. Current, 4.5 amps, label that I. Okay, so then I plug in. Voltage equals current, which is 4.5, times resistance, which is 2. And we know that's going to be 9. What are the units for voltage? Volts, which we represent with V. Okay, so perhaps we're representing we're representing a 9-volt battery, kind of like you'd have in your smoke detector, for example. All right. So this says next one, calculate the resistance through a battery where the voltage is 12 volts and the current is 600 amps. Okay, so this kind of maybe relates more to like a car battery. Okay, most batteries in cars are 12 volts. And, you know, they draw a current of 600 amps, sometimes more, sometimes less. That's kind of what this would relate to. So resistance, again, start with V equals IR. So voltage is 12 volts, that's V, right? Current, 600, that's I. So we have V and I. So V, 12, equals I, which is 600, times R, which we don't know. What's the resistance? Okay, so we'll go ahead, divide both sides by 600. Okay, and what I'm going to end up with is the resistance being equal to 0.02 ohms. Okay, that's the Greek letter omega. All right, last one here. It says calculate the current, so we're trying to find I through the battery where voltage is 6 volts and resistance is 4 ohms. Okay, so again, we'll go back to V equals IR. We're looking for current. So what do we know? We know the voltage, 6 volt, that's V. Resistance, 4 ohms, that's R. So V, which is 6 volts, right? So we'd have 6 equals, okay, the current we don't know, so we're going to put I times the resistance we do know, that's 4. Divide both sides by 4. And what we get is the current being equal to 1.5 amps. Or amperes, right? But we just usually say amps. Alright, so as long as we go back to voltage equals current times resistance, figure out what we're trying to find, what we're given, we can always use this formula to calculate either voltage, current, or resistance. Okay, if we calculate one of those, if we're given the other two. Okay, and just remember things about the relationship. Okay, as I increase voltage, that increases the amount of current that can flow. If I keep voltage constant, and let's say I increase the resistance, so increase the restriction, okay, I'm going to have less current. If I decrease resistance, so less restriction, I'm going to have a higher current, more current can flow. Okay, so just remember that relationship as well. Okay, and there will be a Schoology assignment in the folder for 5.5, and you will have problems related to the examples that we did over Ohm's law. Okay, so until next time, we'll see you later.